Good morning, students. In last lecture, we have done that how to find out the path matrix of a given graph. Like if you have been given this graph, we have found that is there any path from one vertex to any another vertex in that graph? Okay. So for that, we had created this particular matrix. Okay. And there were two methods. Suppose if you are using the Warshall's algorithm, then this is the method that how to find out the path matrix. So this matrix is giving you a when value. If there is a path, means there is a way to go from a node x to z or x to y or x to y, w. Okay. Otherwise it is 0. That means if there is no path to go from y to x, that particular entry would be set to 0. So this was the path matrix that is given by Warshall. So today I'm going to do now Warshall's algorithm only, but that is called Warshall's shortest path algorithm. So this algorithm is very important, and if you have been asked that write down the Warshall's algorithm, you need to write down this. That is how to find out the shortest path. Okay, like here in this matrix, here this path matrix is just giving you is there any path between any two nodes, but the Warshall's shortest algorithm will give you that what is the length of that shortest path. Okay, suppose if you want to go from x to y, then x to y, what is the length of the shortest path? If you want to go from x to w, suppose there are many paths, what is the shortest one path? Okay, that you need to find out. Now this is also called all pairs shortest path algorithm. Why this is called all pairs? Because it will give you the shortest path between any two nodes, between any pair of nodes from this graph. You take either xw, zx, zy, it will give you the shortest path between them. Okay, because we do have another algorithms also, those are called your single source. In those algorithms, you have been given a source node, suppose x. From x, you need to find out the shortest path to all other nodes. But this algorithm will give you the shortest path between any two nodes, between any pair of nodes. So that's why this is called all pairs shortest path algorithm. Okay. So the concept of this is similar to the one that we have done, that how to find out the path matrix, and even the algorithm is almost similar. I'll tell you the similarity, but the difference is that here you have been given one unweighted graph. Weights were not given for these edges, but now the graph that I'm taking over here, in that the weights would be given to us. Okay. So first I'm taking this example I had taken from your textbook only. Suppose this graph is given to you. How many nodes are there? R, S, T, U. 4 nodes are there, and you have been given these weights. Now, in my first lecture on this graph data structure, I had told you what is the weighted graph. In weighted graph, you have been given the weights. Weights means in any application, suppose this is the distance in kilometer. If you want to go from 4 to R, this is 4 kilometer. S to U, this is 2 kilometer. Okay, so this is similar to adjacency matrix, but instead of putting 1, you have to put the weight of that. Okay, suppose if it had been an adjacency matrix. Okay, so this is your R, this is your S, this is T, and this is your U. Similarly here, this is your R, S, T and U. Okay. Suppose if it had been an adjacency matrix, and if you have to write down what is the, is there any edge from R to R here? Actually in this example, we have taken one loop also. Okay. So R to R, what is the distance? 7. Okay. But if it had been an adjacency matrix, it would have been 1. R to S, is there any edge from R to S? Yes, it would have been 1. But now you have been given the weights. What is the weight? What is the number of kilometers to go from R to R? That is 7. So you need to write down here 7. And R to S, what is the distance? 5. So you need to write down here 5. R to T, there is no edge, so it would be 0. R to U, there is no edge, so that would be your 0. Similarly, S to R. What is the way to go from S to R? That is 7. So you will write down 7. S to U is given, that is 2. But S to S and S to T, no edge, so those would be 0 0. Okay, so first of all we need to define this matrix that is called your weighted matrix. Okay, weight matrix you can call them. Here we are assuming that your R1, R is your V1, R this S is V2, T is V3 and U is your V4. So 4 nodes are given to you. So first thing is that you need to define this weight matrix. Okay, and then you here it is given that what is the weight matrix. First, in the previous lecture we have done path matrix. The path matrix tells us whether or not there are paths, but we need to find out now the shortest path between the nodes. So I'm defining one variable qij, that is the length of the shortest path from vi to vj. Okay, now in the path matrix, while finding that, we have defined the matrices like P0, P1, P2 and P3. Just see P0, P1, P2, P3 and P4. Here also we will be doing the same thing. First I will be defining one matrix. Suppose I will call them Q0. Then I will be finding Q1, Q2, Q3 and Q4. And the formula is also going to remain same. What was the formula while finding the path matrix? It was that if you want to go from I to J through node K, okay, it can be the previous path, or you are going from I to K then K to J. Now here also similar thing, just see here. So this formula is important. First is what is Qij? Qkij is now the smaller of the length of the preceding path from Vi to Vj, or the sum of the length of the preceding path from Vi to, this is Vk, and from Vk to Vj. That means you want to go from I to J. Now there are two things. One is that first you will define K is your, suppose 0, Q 0. That means you are not going through any another node. You are going directly from I to J. There was a direct edge. Now you want to define, suppose Q1ij. Now what's the meaning of Q1ij? Q1ij is that now there can be two paths. You want to go from I to J through what? Through the node Q1, through the node V1. Okay. Now it may be there may be one path that I to K you are going, and from K to J. You take the summation of those two and then compare that with the previous path that you had defined for Q0 Ij. Okay. Now the summation of these may be lesser than the previous length. In that case, you will take that the length is this one. Otherwise, if the summation of these two is greater than the previous length, you need to take the previous length only. Okay. So, what's the formula? That Qkij, that means you want to go from I to J through this node K, then the distance between them may be this one or this one. This is the previous one. That means you are going I to J through the previous nodes K minus 1, or from I to K you are going, and then from K to J. Okay. So in the path matrix we have defined P0, P1 till Pm, where M is the number of nodes. Here you will define Q0, Q1 and Qm. Okay. I'll take one example again, otherwise I will come to this formula. So this is your graph that I'm taking, and suppose we need to find out what is the shortest path between different nodes. Okay, so first of all you need to define this weight matrix. This is your Q0 now. Okay, now take Q0. Q0 is similar to your this weighted matrix, only difference is that these zeros are being replaced by infinity, because initially we are assuming that there is no way to go from, suppose, this R to T. R to T was 0. So in this I will be taking R to T as infinity. Okay, then we will find out the shortest path. So what's the meaning of Q0? Q0 means there is a direct edge from R to R. There is a direct edge from R to S, and the distance of that is 5. So even the paths are given RR, RS. If you want, don't write down this. These matrices are important. Okay, and what is this 3? 3 is your TS, means directly you are going, direct edges are given. That's why only two nodes are written, RR, RS, SU. Okay. Next is now, these things are now important. You need to find out Q1. Okay. Now I would take this entry 7, 5, infinity, infinity, that is going to remain same. I will tell you how it is. First I will take that entry that is changing. Now here R, this was your S and this was your T. S to T, it was firstly infinity. Now it is 12. Now what's the meaning of that? No, this is S to S only. S to S. Now it is saying that Q1. Now what's the meaning of 1 over here? 1 means your V1 node. V1 node is your R node. Okay. It is saying that if you want to go from S to S, okay, and if you're going through R, that distance may be lesser than the previous one. Now what was the previous distance from S to S? From previous distance was your infinity. So I'm writing that over here, infinity. Now you take the new distance. That means you are going S to R, I to K, S to R. What is S to R previously? You write down here, this is RS TU and this is your RS TU. So what was the previous distance from S to R? S to R is your 7. So I'm writing that 7 plus S to R is 7. Then R to S. What is R to S? That is 5. So 7 plus 5. So that means out of these two, which one is minimum? This one. That is your 12. Okay. That means if directly you are going from S to S, that distance was infinity. But if you are going through R, that means S to R and R to S. While finding these entries, you need to refer to the previous matrix. So while finding Q1, I need to use the matrix, this matrix Q0. Okay. So which one is minimum? 12. So I will write down 12 over here. Okay. You take one more entry. This is U to S. So previously, if you want to go directly from U to S, what is the distance? That is your infinity. You can check the graph also. If you want to go from U to S, there was no direct edge. Now I'm saying, let's suppose we find out that through R, if I'm going through R, what is the distance? Okay. Now again, U to S is your infinity. Now I will find out through R, U to R. This was your U, this is R. What is U to R? That is your 4. I'll write down here. Otherwise again, this is R, S, T and U. And this one is your RS, TU. Okay, RS, T and U. What you need to find out? U to S. What is the distance? Firstly, it was infinity. Okay, now I need to find out through 1. Through 1 means through R. That means you can go from U to R and then R to S. So U to R is your 4 plus R to S, that is your 5. So 5 plus 4 is 9. That means this is better. So I will write down 9. That means if I want to go from U to S, I will go from U to R first and then from R to S. Okay. And if you want to use this entry is your, you can find out like this also. Okay. Suppose you need to find out 4, 2. This entry is your 4. This is suppose your 1. This is your 2. This is your 3. And this is your 4. And this one is your 1, 2, 3 and 4. Now what you need to find out? I need to find out Q42. So put that value in the formula. Q42, I need to find out this entry. Okay. Through which node? Through one node. So K value is your 1. So what it would be? What? It would be minimum of what? Q0 42. Now what is Q0 42? That is your infinity. Okay. So I will write down infinity, comma. It would be Q0 4 to 1. I then K. 4 to 1. Q0 4 1 is your 4 plus Q0 1 2. 1 2 is your 5. So minimum of infinity and 9. What is the minimum? 9 is minimum, so you will write down 9 entry over here. Okay, so this is written over here. You need to find out, suppose Q142, it will be minimum of, okay, k value is 1 in that formula. Now it was k minus 1, so it would, if it is 1, it would be 0, 42, or comma Q0, you are going 4, I is 4, 4 to k, k is your 1, so 4 to 1, then k to j, 1 to 2, okay, through a one node. So it is minimum of infinity 4 plus 5, you are getting 9. So like this way, actually you need to find out all the entries. All the entries you need to check, even these one also, but these one are not changing, they are remaining infinity only. Next you take Q2. Here this value is changing. You first take this one, why it is not changing, then find out this in entry Q2. You want to go from 1 to 4. Okay, Q2 1 to, okay, here it is Q2 1 to 3. Q2 1 to 3. That means I want to go from 1 to 3 through which node 2. Now while finding these entries, you need to take the help of this. Okay, Q1. So what would be that? Q213 will be minimum of, k is now 2. So here k minus 1, Q113, or it would be Q1 1 to 2. You are going, then 2 to 3, means I to k, k to j. 1 to 2 plus 2 to 3. Now Q113. What is Q113? This is 1, this is 3, this is your infinity. So you will write down infinity. Then you need to take these entries 1, 2 and 2, 3. 1 to 2, that is your 12, and 2 to 1 to 2 is your 5, sorry, and then 2 to 3, that is your infinity. But 2 to 3, that is your infinity. So 5 plus infinity, so it would also be infinity only. So what is the minimum of infinity? Infinity, that would be infinity. So that's why this entry is not changing. Okay, this entry. Next you can find out this entry, that means you want to go from 1 to 4, that means R to U, through which node? Through S node. Okay, so that may be lesser than the previous one. Previous one is infinity, but if when you are moving through S, it would give you 7. So this is your initial matrix. This is through vertex R, 1 is R. This is through vertex 2, that means S. Then you are finding through vertex T, through vertex U. Okay, so this is your final answer, that you would be getting this. Okay, and what is that? That is that if you want to go from, you take suppose U, this was U, this is your R, S, T and U. If you want to go from U to T, okay, that is your direct edge, that's why the path is UT. But if you want to go from U to U, that is the path U to T, T to S, S to U. Okay, and if you want to go from S to S, this is the path, if S to T, SUT through U. Okay, so if you want, don't make these matrices, you just need to make these one. Okay, so in your graph, if there are 4 nodes, you need to find out Q1, Q2, Q3 and Q4. Okay, and Q0 is similar to your weight matrix that is given. Q0 is similar to this weight matrix. Only thing that you need to change is that 0 is being replaced by infinity. So I have used this formula that QKIJ is minimum of Qk minus 1 ij or Qk minus 1 I to k plus k to j. Now this algorithm is similar to the one that we have done for path matrix. Only thing that is changed is this formula. Okay, so first of all you are defining a Q0. Q0 means you are defining a Qij, because I won't write down Q0 Q1 over here because each entry is being replaced by the previous one. So I'm assuming that W is given to you, weighted matrix is given to you. So in that entry, Wij is 0, Qij would be infinity. Otherwise, Qij is equal to Wij. That means Q0 is similar to your weight matrix. Only difference is that all zeros are replaced by infinity. So when you have to use this formula, first you need to take K loop, because this K loop is for the number of matrices that you need to find out. If M is your 4, that means you need to find out Q1, Q2, Q3 and Q4. So this matrix, this loop is for that one. And this is that you need to find out each and every entry of those matrices. So I is changing from 1 to M, J is also changing from 1 to M. And you are writing Qij should be minimum of Qij, that is the previous one, or you are going from I to K plus K to J. Okay. So after executing these 3 loops, you will be finding the last entry, that is your Q4, and that is your answer. Okay. So here again I am repeating that these are not different matrices. While doing manually, we have written them Q0, Q1, Q2. Actually, this is a single matrix Q. So first single matrix is your this one Q. While finding this Q, each entry over here is being replaced by this. Okay, each entry over here is being replaced by these entries. So this won't be there. This is being replaced by this. Now while finding this in that algorithm, each entry over here is being replaced by this one. Okay. Next is your that you need to find out Q3 and Q4. So this is also your Q. This is also your Q, and this is the last Q when your K is 4. When K is 4, and for each value of I and J you are finding these values, this is the answer. So your answer is this one. Okay. So you can take some more example and you can find out the shortest path between any pair of nodes by using Warshall's algorithm, by using this formula. You need to use this formula when you will practice directly. Like you can write down Q1 from this, Q2 from this one, and Q3 and Q4 you can find out. Okay. And one thing more, if you have been given 3 nodes, you need to find out till Q3 only, because there is no 4th node. And if you have been given 5 or 6, you need to find out Q5 and Q6 also. Okay. And this algorithm is very important, so do this numerical also, and you need to do this algorithm as well. So this is very important algorithm. Just go through this, it's very simple.